Welcome back to another video on my channel, math_exe. Today we're going to look at even more examples of linear function problems. So for the first one, find the values of a in each case. So let's just write that down over here. For part 1 of part A, the function y equals 2x plus a passes through point P 2, 5. So let's just write that down, y equals 2x plus 8, and the coordinates, we don't really care about the point, we just care about the coordinates of the point. In this type of problems, in this case the coordinates of 2, in this case 2 is the x coordinate, 5 is the y coordinate, and therefore we can just substitute its corresponding x and y value into the equation, because we know it lies on the this line right here. So after substituting this, we'll get that it will be 5 equals 2 times 2 plus a. You can just do all that stuff and you'll get that a is equal to 1. This is the first answer. For part 2 of part A, you basically do the same thing. So it says that the line y equals ax plus 2 passes through point 3, 3. Right, just substituting its x and y value in, you get that this will equal to 3 times 3a plus 2. And therefore, simplifying this, you get that a is equal to 1/3. For the third part, it's slightly different, but you can just do the same way. And it says the function y equals negative 3x minus 1 passes through point 1, a. So first we have y is equal to 3x minus 1 and point 1, a. Let's see, I've rewritten this right? Yep. Just substituting its x and y value. Notice the x coordinate right here is 1, the y coordinate right here is a. So that means a is equal to negative 3 times 1 minus 1, which is negative 4. For the fourth part, it says that the function y equals 10x minus 12 passes to point S at a, 18. So let's just rewrite that. Alright, and you can just substitute each x and y value. The x coordinate right here is a, the y coordinate is 18, therefore it will become 18 is equal to 10a minus 12. That means a is equal to 3. That's we're done with part A. Part B, given a graph of a function as shown, and it's given that it intersects the y-axis at 0, a, and it intersects the x-axis at a, 0. And then we need to find the equation of y in terms of a. So we know 2 points, and therefore we can just find the gradient real quick. So the gradient will be, I'll just write the coordinates right here. So the x-intercept will be 0, a, and then the x-intercept will be a, 0. And in this case, I'll just take 0 as y or y2 value, and I'm supposed to write the formula right here. Or you can just say it's y is overrun, as the fancy name says so. So if y2 is 0, then y1 will be the other. And if 0 is y2, then this will be x2, and 0 on here is x1. Alright, so let's just plug in those values. So I have 0 minus a over a minus 0, which simplifies to negative a over a, or just simply negative 1. And next thing we want to find is the y-intercept. However, it's already given right here, since it clearly intersects the y-axis at 0, a. We only care about the a right here. So therefore, we can conclude that using our Poinsot formula for an equation of a linear function, the equation is y equals negative x plus a. Alright, we're done with the first question. Let's jump into the second one. Alright, for the second question, it is another application of this linear function type problems. So it says the height of a plant 8 centimeters after t days is given by the function h is equal to 10 plus 0.5 t. And we have this table right here. Well, it's pretty simple. You can just substitute in a given value, either t or h, and then from that you can just solve for the unknown. And after you have done that, what you're ending up, part B is the drawing part. On the scale of 3 centimeters to represent 2 units, I'll just write that on the side for on the t-axis. I'll just write t is 3 for 2 units, and keep in mind t values between 0 and 12, and a scale of 2 centimeters to represent 2 units on the h-axis. So let's just write that scale. And h values between 0 and 16. So I'll just change the axes right here. So I have t as the x-axis and h as the y-axis. So I just plot our points for the t-axis. It says, so assume we want to plot point 2 somewhere right here. You need to ensure a distance of 3 centimeters as the scale says so. And then you keep this constant measurement or scale between each 2 points of this t-axis. And I'll just jump in when I'm done plotting this. Alright, so that is the plotting of the t-axis done. And then we can just remove the scales right here. It would be very appreciated if you do this in this scrap of graph paper, because these type of questions are very common in some example problems of these types. Anyways, now we need to plot the h-axis. So we're going to take only the h values between 0 and 16, and we use a scale of 2 centimeters to present 2 units. Alright, so let's say the point 2 is somewhere right here on the h-axis, and you must keep a distance of 2 centimeters all the way to point 16, and your h-axis should look like this. Alright, so that's the h-axis done. Now we're ready to plot some points given by the table that we have just filled in. So let's just plot the first point as t equals 0, h equals 10. So that point is right here. And then we just erase this scale since we don't really use it. So yeah. And the next point is t equals 2, h equals 11. H equals 11 is halfway between 10 and 12, so it's somewhere right here. 2 is right here. This point is somewhere right here. Next point is 4, 12. It's right here. And then next is 6, 13, somewhere right here. And then you can just do this all and on. But I'll just finish the function anyways. So let's just draw a line like so. Alright, so that is the function, and don't forget to label the equation of the function. So in this case is h is equal to 10 plus 0.5t. And then with this graph, you can just solve part C. Use your graph to find the length of the plant after a week. And keep in mind, a week is just 7 days. So we can just substitute in t equals 7 because t is in days, and then we're on the same page of the measurements. So let's just draw a straight line from t equals 7, which is midway between 6 and 8. So let's just draw a straight line that's somewhere right here, and then let's just draw the other line. And what you ended up is, this is not very accurate enough, and the result when t equals 7 will be h equals, so when t equals 7, if you have the measurements accurate, it will be equal to 13.5. So the height of the plant after a week will be 13.5 centimeters. So let's solve the next part, which is the time needed for the plant to reach a height of 14.5 centimeters. So 14.5 is halfway between 14 and 15. 15 is somewhere right here, so that means 14 is somewhere right here. So let's just draw a straight line to the function. So it crosses the function at around this point, and you can just draw a straight line, and what you will get is t will be equal to 9 when h equals 14.5. t will be equal to 9. Alright, so that's it for this question. Let's jump into the third one, sorry. Alright, for the last question, the third question is a coordinates type problem, and involves something with gradients. So first we need to state the coordinates of point A and point B, which is pretty simple. So in this case, point A, we look at the x coordinate first, which is -2, and the y coordinate is 0 because it lies on the x-axis. And the coordinates for point B will be, first we're going to write the x coordinate, which is 4, and then the y coordinate, which is also 0 because it lies on the x-axis. So we're done for the first part of part A. For the second part of part A, it's not that difficult to see that AB is a straight line, specifically a horizontal. So let's just write AB is horizontal, and therefore the gradient of any horizontal line, no matter where they are, how they are placed on the xy plane, will be equal to 0. So the gradient will be 0. Alright, so let's just quickly erase some details we don't really need because it will take some space. Because on the next part, part B, we're going to find the coordinates of point C such that C lies on the line y equals 3. So first we're going to, it's probably better to draw the line y equals 3. Notice that y equals 3 is a horizontal line that intersects the y-axis at y equals 3. So it will look something like this, such that C lies on the line y equals 3. So, well, we already know our y coordinate for C, so let's just say C is somewhere right here, but we really don't know yet. So let's just say the x coordinate is x, and its y coordinate is obviously 3. Actually, let's not just write x. Let's just kind of picture this problem. So the question is, where should we slide C on the line y equals 3? So for example, right here, testing right here, right here, right here, and you can just move C freely as you want, such that if you connect the lines A, B, and C, all connect the lines, it will form an isosceles triangle. And the way I've come up to the solution of this problem is by how you draw an isosceles triangle. So basically, how you draw an isosceles triangle is says so first you draw a straight line right here, and then you take the midpoint of this line, and then draw a certain amount of distance from this, and then label this point. And if done correctly, or the measurements are accurate, this side right here will be equal to this side, which is what we're going to implement in the problem. So first, let's suppose that AB is the base. And then first we need to find the midpoint, and that's pretty easy to see. We can just take the average of the x coordinates. So the average of the x coordinates is -2 plus -4 all over 2, which is 2 over 2, which is just 1. So the midpoint is x equals 1. And then if you draw a straight line over here, and this is where y equals 3 is, and notice that you can just do this on the graph paper if you want. This side must be equal to this side, and you can just do it with a ruler and notice they are the same. So we have found our C coordinate, which is the x coordinate is 1 in this case, and then our y coordinate is obviously 3. So let's just write our answer. First part of B is C at 1, 3. And for the second part, we need to find the area. It's not pretty hard to see. Remember that the formula of a triangle is the half times base times height. So we have assumed that A, B is the base. So let's just calculate the distance between A and B, which is just the difference between the x coordinates, which is 4 minus -2, which is 6. And then from the height, this segment right here, well, it's just the distance between y equals 3 and the x-axis, which is just 3. And therefore, we can just use the formula. So the area is equal to a half times our base, which is 6, times our height, which is 3, which is 9. And for the last part, find the possible coordinates. And what I mean by possible coordinates, it means there are possible values of the coordinates of point D that also lies on the line y equals 3, and ABCD is a parallelogram. So one of the main characteristics of a parallelogram, it has 2 pairs of parallel lines. So let's just implement that in the problem. So let's just draw a line which has the same gradient, or in other words, it is parallel to the line segment AC. So let's just extend this right here, and then let's just draw a line segment that is parallel to AB. And that point of intersection is where point D is. However, this is not the only possible D coordinate in this case. there is in fact another one if you do it in a slightly different way. You can also draw a parallel line which is parallel to the line segment BC. So I just draw that right here, and then you can just do the same thing right here, and the point D is also right here, but the point D is could be also right here on this line. So actually there are two possible D coordinates, and if you do this in a sheet of graph paper, it will be much more accurate than this. The possible D coordinates of point D are D at, well, the coordinate that we found on the first way, which is at 7,3. That's the first possible value. And the second one is at the negative 5,3. There we go. So that is the last question, and that ends the video. So hopefully you guys enjoyed this video. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.